Hi folks, welcome back to Physics with Captain Rod, making this video here to help you out with number 21 in your Unit 2-1 homework. So when I look at the homework problem, there's a whole bunch of things asked for. It really boils down to this: solve everything you can in this problem. All right, so we've got this 9-volt battery right here hooked to these capacitors, and this is hopefully obviously a equivalent capacitor system. One thing I'd like to point out, these values are all given here, here, here. These are all numbers known in the problem. I'm not sure why they typed this one here and not the rest of them, but they're all there. So give me a moment here to save myself a little work here. Whoops. Okay. The idea here now is to simplify these things down. So what you're going to do is you're going to take these right here. Actually, let me back up a second. I'm sorry. Let's draw charges. So we're going to have charges here. Let's call this one Q1, here, Q2, Q3, and Q4. Right, and these are things that you're trying to find are those charges. Okay, now these two here hopefully obviously are in parallel. So find their equivalent, redraw the circuit, and in the place of those two you put their parallel equivalent. I'm going to sketch this here, and I'm even going to try to honor the color that they use for those capacitors. Okay, C equivalent, and again that's coming from these two. All right, now let's put our charges in here, right? This thing's charged to the following polarities. Oops. All right, so this one was the one I labeled right here. I think I called that one like charge 1. Now this is some charge here, but it's not 2 or 3. It's actually the sum of the two. I'm just going to leave it as Q for now. And then this one over here we got labeled as Q4. Now, these things are in series, I'm noticing. And right, when we look at this, this is a series deal. So these charges, here, here, and here, you have to make a decision about them. I'm not going to tell you. I'm just going to say same or not the same. And remember, this is a series situation. Okay, now, these 3, here, here, and here, are all in series. So calculate an equivalent capacitance. And then what we do is we go to this picture and we replace all of it with a single capacitor . I'm going to call that C equivalent. Let's see, I already called that one. I'll put a prime on it there. It's for the whole system. It's not the same as this one. Then you can calculate the charge on this. Then you come over to this picture and decide what does that mean for these 3. And remember, this is a series deal. And I like to think of it like this. As far as the battery is concerned, this plate right here is this one in this picture. And this plate is this one. So hopefully that will help you out with that. I don't want to just tell you the answer of it. But again, this is a series deal. That tells you something about the charges. Once you have the charges on each one of these, you should be able to calculate the voltages across these as well. Because your delta V is, let's see, hold on, capacitance is charge over voltage. So voltage, your delta V is charge over capacitance. Then you can calculate the voltage on every one of these. Then we can move back to this picture and we'll know the voltage here, and we've got the charge on it anyway. We would know the voltage here, and we've already at this point have the charge on it. But we would also, again, once we know this voltage, we would know the voltage here across both of these, allowing us to calculate charges 2 and 3. So it's very important with these that you learn how to simplify them, redraw your picture. Do not skip this picture, do not skip this picture. Because the idea is you have to simplify it down to one capacitor, find the charge, then you start working back through your pictures to get the original information. So that should be enough, I think, to get this thing done. I hope that helps. Have a great day.